Okay, so Caleb's here and I marked him absent.
Okay, I can get that. Caleb here, Luke and Logan,
Vanna,
Vanna's there.
yeah, evidently she's gonna. I marked her absent too. Of course, my battery's dying. Okay. Good morning, guys. All right. So I gotta get. We gotta finish up lesson 2. Oh, I thought I knew how to plug this in. There we go. Okay. All right. Need this. Okay. So, um, that's not what I want to do. So right now, if you haven't, go ahead and complete the sequence. Okay. All right. 2.3, guys. Everybody complete that sequence. Okay, so let's talk about this sequence. Does someone want to share what they got for number 1?
12 and 48.
12 and 48. Okay. 12 and 48. Okay, and then the next part of the problem is that we'll go ahead and look at, let me do this. On part B, you had to tell what the growth factor is. Okay, so what did you do each time to get the next number in the sequence, the next term? You multiply by 3. And what did you say, Elizabeth?
Wait, are we talking about A or B?
A. We're talking about A.
Oh,
Multiply by 2, right. So for letter A, you multiply by 2. Okay? All right, so going up. Now, what about letter B? What was the next two numbers? Okay. 1,080 and 3,240. Okay? So that particular growth factor for letter B, you'll determine it to be what? Multiply by 3. Okay? All right. Letter C. What was the next? 0.2 and 0.002. Okay? So how did you find it? Okay? Now, you did divide, but when you write it out as a growth factor, you don't write it as division, okay? You have to flip it and rewrite it as, right, so it'd be multiplied by 1/10. Y'all see how, remember, division is just the opposite of multiplication. So in sequences, you can't write it as division, okay? You have to take that number and flip it. So remember, when you're in division with fractions, it's the same as multiplying by its reciprocal, and that's what we're doing. We're multiplying by the reciprocal of being divided by 10 over 1. It's being multiplied by 1/10. And I should have put multiply by 1/10. But yes, you can use division to solve for it, but when you write it out to describe it, because it's being a geometric sequence, you have to write it as multiplying by the reciprocal. Okay. Looking at D. What do we think about D? Okay. 3/7. You're close. It's, yeah, 81/7, isn't it? Okay, so now when you think about what was its growth factor, what's happening each time? Multiply by, actually, yes. Multiply by 3 over 1. Because the denominator's not changing, is it? No, the numerator's the only thing that's changing. So it's, you could say multiply by 3. That's the same thing as 3 over 1, okay? The 1 is just holding a place value, but a whole number has an understood what for its denominator? A 1, right? If you see a whole number and they say write that as a fraction, you always put it over 1. Okay, do y'all remember talking about that in algebra? A whole number always can be a fraction. It's just a whole number over 1. Okay, letter E, what happens with it?
Multiply by 1/2.
Okay, so the next two numbers,
3 and 1/2.
3 and 1.5, right? Okay, so you're basically taking half of the number, so, but you can't say divide, so you have to say it as multiplying by the reciprocal, so it's multiply by 1/2. Okay? And that's what geometric sequences are. It's a matter of figuring out the growth factor. Could it be a fraction? Yes. Can it be a whole number? Yes. But the whole thing with this lesson is that you understand that completing the sequence is multiplication of some constant. That's what's changing each time. Okay? Questions about that? All right, let me go back. I want to, let me find, well, where did it go?
So let's talk about explicit formulas for geometric sequences. An explicit formula is not a recursive formula. And remember, recursive formulas require previous values to find future values, but explicit formulas do not. So let me show you an example of one. So 3 times 2 to the nth power equals a sub n is an example of an explicit formula. It tells you that the term a sub n can be created by taking 3 and multiplying it by 2 to the nth power. So if I want to find the first term in the sequence, or a sub 1, I substitute a 1 in for n, 3 times 2 to the first power, simplify, and I get my first term, which in this case is 6. And if I want to find the second term, I substitute in a 2 for n, which gives me, a 2 for n, which gives me 3 times 4, which is 12. And if I want to find the third term, I do 3 times 2 to the third power, which would be 24. And I can continue doing this and generate the sequence. Now, the benefit of an explicit formula is if I want to find the 50th term, I can just plug in a 50 and get the value of the 50th term. If I had a recursive formula only, then I'd have to know 49, and then 48, and 47, 46, all the way down to the first term, which is not fun. So that's the benefit of an explicit formula. Now, the hard part of sequences is being able to write an explicit formula. So now let's try to use a very simple technique to find the explicit formula for this sequence. So first thing I have to do is check to see if it's geometric, which means I have to see if there's a common ratio. So turning a 15 into a 45 is a times 3, and a 45 into a 135 is also a times 3, and a 135 to a 405 is also a times 3. So there is indeed a common ratio, and it is 3. Now from class, you recognized that the common ratio turns into the base of an exponent, because in a geometric sequence, that repeated multiplication is rewritten or can be rewritten as an exponent. So I know, because it's geometric with the common ratio of 3, that my sequence's explicit formula has to have a 3 to the nth power in it. And what I'm going to do now is I'm going to test 3 to the nth and check if it works. And if it works, yay. If not, what I'm going to do is fix it. So 3 to the nth generates the sequence 3, 9, 27, and 81. And it's not correct because I don't know where 15 and 3 are the same thing. But I can fix it. If I can first look at this term here and look at that term there and think, well, how can I turn a 3 into a 15? And I want to use an operation, and I could, of course, add 12, because 3 plus 12 is 15, but if I check plus 12 with 9, I get 21, which is not that next number. So I know it's not a plus 12. Well, another option is to multiply by 5. So if I take 3 times 5, I get 15, and then 9 times 5 gives me 45, and then 27 times 5 gives me 135, and 81 times 5 gives me 405, which means I have found the sequence by taking this 3 to the nth power and multiplying it by 5, which means the explicit formula that I need is a sub n equals 5 times 3 to the n. So the technique is very simple. You're going to take the common ratio, raise it to the nth power, see what it gives you, figure out what's wrong, and fix it. So what was wrong in this case was that it was 5 times too small, so I just had to multiply by 5. Now, if you really didn't like that process, there's a formula you can use that appears in just about every textbook and every web page about geometric sequences. And here's the formula. It says a sub n equals a sub 1 times r to the n minus 1. Now I'm going to show you where this formula comes from. So first off, we know r is going to be the common ratio, and we know a sub 1 is the first term. So if I think about a geometric sequence, of course it starts with its first term. Now to find the next term, remember, you have to multiply by the common ratio, or r. So you get a sub 1 r. And to find the next term, you have to multiply by r again, so you get a sub 1 r squared, or r times r, which is r squared. And then to find the next term, I multiply by r again, and I get a sub 1 times r to the third power, and then I get a sub 1 r to the fourth power for the next one. Now if I look at which terms I generated, this was the first term, that was the second term, that was the third term, that was the fourth term, and that was the fifth term. And I think about, well, remember, an explicit formula is the formula that relates the number of the term to the actual value of the term. And 2 became a first power, 3 became a second power, 4 became a third power. So this exponent is actually 1 less than the term number, which is why this is n minus 1.
All right.
So if we look at this sequence, I see the signs are alternating. So that means that the common ratio is going to be negative. And what turns a 4 into a negative 12? Well, that's a multiplication of negative 3. So my common ratio is now negative 3. I know it has to be negative 3 to the nth power, or it has to have negative 3 to the nth power. Notice how I wrote that in parentheses. It has to be in parentheses if the signs are going to alternate. So I'm going to test this. So this one generates negative 3, 9, negative 27, positive 81, dot, dot, dot. So now let's look at this sequence and see what's wrong. Well, there are a lot of things wrong. First, this one starts negative, that one starts positive. So let's fix that. How can I fix the sign difference? Well, I can just multiply this sequence by -1, and what that's going to do is alternate the signs. So now I have a sequence that has the correct signs, but these numbers are not the same. A 3 is not a 4, so how can I turn a 3 into a 4? Well, I can add 1, but that's not going to work with the very next term. So now I have to figure out what I can multiply by. And there are two ways that you can do this. One way is just to figure out what to multiply 3 by to get 4, which is 4/3. But if you're really uncomfortable with fractions, you can take this in 2 steps, because I can always divide this whole thing by 3 to make that a 1. So if I divide this sequence by 3, I get a 1, a -3, a 9, and then a -27. And now it's really easy to turn a 1 into a 4, right? All I have to do is multiply it by 4. So if I take this and I multiply it by 4, and I'm going to write that as -4 times -3 to the n over 3, and I test it, I'm going to get this sequence multiplied by 4 for -12, 36, -108. Now you could have done this in a single step if you recognized right here that you had to multiply it by -4/3, but number of steps doesn't matter. What matters is, can you figure out the correct formula?
Okay. So that's what we're doing with this explicit formulas. It's part of the geometric sequences. Well, come on. There we go. All right. So if we go back to what we just did and think about the sequence, okay? These would be our first, second, third, and fourth term, right? And the explicit formula, yes, our common ratio, what we talked about was 3. Okay, no, I'm sorry, it's 2. But then you have to figure out what else is it being multiplied by, to get the next sequence. Okay, and that's what explicit goes with geometric, and recursive goes with arithmetic. Okay, and we're going to get into that more in lesson 3, but I wanted you to see that video just to see how it's connected to geometric and the recursive. We watched the arithmetic sequence video, and what she developed there was the recursive formula. Okay. All right, so to tie all this up together, if you look at the summary, okay, if y'all look at the summary, okay, they said consider the sequence 2, 6, 18. How could you describe that? Okay, so it says that you're multiplying by 3 each time, okay, and that's correct. And we're going to be able to write a formula with our sequences in the next lesson. But I wanted you to see how, in the video, how just a glimpse of what it might look like. And this one, it says it's 3 times the previous term. Okay, so this would be an example of a geometric sequence, because geometric is multiplication, where the arithmetic one, arithmetic, is addition and subtraction. Okay, so it's considered a growth factor. What's happening each time from that previous number to the next? It is growing in some form, either by a fraction or by a whole number. Okay, and also is identified as the common ratio. Now, if you go on down, this one is not a geometric sequence, okay? What's happening each time? It's not multiplication, is it? Addition. They're adding 2 each time, so that one would be arithmetic. Now, if you saw something like this, okay, if you saw something like this, you can have neither. Okay, so what I want you to understand is there could be times that the sequences do not fall into arithmetic, geometric. It's just a sequence that someone said 1 5 1 5 1 5. Okay, that doesn't have a pattern. It can't write a formula to it. Therefore, it's not either one. Then they gave you this one. Okay, you start with a big number going down to a small. What are they doing? Well, they're dividing, but to write it as a growth factor, we know we have to change it to a fraction, don't we? Right? So the growth factor would be multiply by 2/10 or 1/5. So that's what I need for you to understand is when you explain or write out what it means, it's not division, okay? It's multiplying by that fraction. Do you divide to figure it out? Yes, okay? It is division when you're trying to find it, but when you describe it, it's multiplied by a fraction, okay? Don't describe it as division. I know that's confusing, but do y'all understand what I'm saying? Everybody understand? Okay. All right. So I put the cool down on, if you want to do it just on a piece of paper and turn it in, you can do it that way, or it's on Google Classroom. Okay. All right. So I'm going to give you about 15 minutes to look to try to answer this cool down for me. So we're working on the cool down for lesson 2. So Caleb, we're working on the cool down that I have shown. Or you can do it on Google Classroom. Have y'all taken the quiz? Did y'all take the quiz that was on Google Classroom? No?
I know it was
Okay. All right, let's see here. Okay. Yeah. There's a quiz and this ed puzzle is an assignment that needs to be completed. All right. And have you have y'all logged into Khan Academy? Yes. So if you haven't done the quiz, you need to go ahead and do that. And those of you that are online, if you haven't done the quiz, you need to do that as well as you finish up the cool down. All right, so Andrew, you need to do the cool down, and then the next thing we're working on is the quiz. Yes, yes. So the cool down's not in your book. It's either online or you can write it on a piece of paper from up here, or you can do it on Google Classroom. So as you finish those assignments, just let me know and you can close your Chromebook, okay? But for sure, let's finish the ed puzzle, the quiz, and the cool down, okay? If you haven't done that. So those of you that are online, you need to finish the cool down, take that quiz that's on Google Classroom, and complete the Ed puzzle assignment, okay? All of those things are due, so do that for me. It's the one where it takes the previous number and either add or subtract to it. Explicit was the one we just did, ratio multiplication of the ratio to the power. Yes, I know the quiz is a lot harder than I thought it was, but just do the best you can.
So could it be one or the other? Would it necessarily have to be both?
No, I don't think it. Okay, so it has to be recursive. It's not both. Oh, it's asking both? Okay. So, as I told the other classes, I hadn't looked back at it, just what I'm gonna do is look to see what was missed the most, and look at the problem and see what you put. So it's not going to hurt your brain, just, I mean,
I would think that you said that, I would stick with that.
yeah,
I would stick with that.
just give me the best you got for now, and then I didn't realize I'm new at setting these quizzes up, so this is probably not my best effort. I thought it was correct, but we're gonna do it different. But just show me what you got. Yes. The quiz? No, because the quiz, several classes were telling me it was really harder than what I thought I made it. So I'm gonna look at the ones that you got right overall and the ones that overall the class missed. And do an average, so no. You're welcome. Well, I just had a student go out. I forgot. Oh, Elizabeth, so I can only let one at a time. So again, on that quiz, everybody just give me the best you got. okay? Don't panic, okay? Don't panic. Just do the best you can with it. So Joshua, we've done all of those, okay? Can you get logged into Khan Academy? Okay, all right, just checking, okay? It's fine. No, it's fine, just. So if you get done with all of that, you could go ahead and start on the practice for lesson 2 in the workbook. 'Cause that's your homework. It's gonna be the lesson 2 practice. Yes. So guys, those of you that are online, once you finish the cool down, the ed puzzle assignment, and the quiz, then move on to work on lesson 2 practice, okay? sequence right there. So, yes, yes.
Carol Bird,
Yes,
that's not terrible.
really. She is a sweetheart. Yeah, I worked with her at ASU.
She was a treasurer or something like that.
Uh-huh. She doing okay?
Pretty good, young lady.
Well, that's awesome. I'm glad you told me that. You have to tell her I said hello.
Already.
Yeah, that's fine. That was the best. So sad. All right, everybody doing okay? So we're finishing the quiz, the F puzzle, the pull down, and work on the practice problems, okay? You guys online okay? Y'all all right? Okay. Somebody's gonna get the money. Yes.
You want to all together and do,
And, oh, okay. Yes, the Khan Academy, yeah. Now, some of them are videos, and then some are.
Okay.
Did you already complete the? You might want to work on that, because you've got to, about the end of the month on the call.
Okay.
So. I think we did, yeah. Yeah, 100, so I think we did it volunteer today. Yeah. Yeah, and you can leave it on time and comment. Yeah. And probably what can happen is, after we get further into these lessons, we might keep up quiz again. Trying to, I mean, I can reset the quiz and, you know, I'm gonna look at, see what how y'all did, so don't panic. Cause it's still a learning experience that not like we. Yes. A person owes $1,000, okay? And the credit card charges interest over 2%. So what's happening is it's 1,000 times 1.2. Okay, because every month from the previous is charged 2% interest. So if you multiply by 1.02 is the 1 month prior plus the 2%. Okay? So if you multiply again, times 1.02. Okay, from the previous, like it's this one whole number, and then times 2% to get the new total. Right? So multiplying by 1.02. Yeah. Yeah, while you got it, I would just work on the con while you got it. Oh, okay. Yes, yes. All right, so guys, I'm gonna log off the Zoom. Y'all just keep working, get those 3 major things done, okay? The ed puzzle, the quiz, and a cool down, and then work on the practice problems. That'll be due for the next class, okay? Are y'all good? If you have any trouble, just send me an email, okay? Okay. And then I'll see y'all on Thursday. All right? Have a good day.